Welcome to another tutor short provided by the Educational Support Services Department of Lehigh Carbon Community College in Schnecksville, Pennsylvania, which is just outside of Allentown. These videos review key learnings for the science courses provided here at L-C. And please remember that the Educational Support Services Department does provide walk-in tutoring 5 days a week. Today's video will be an introduction into organic chemistry. And organic chemistry is the study of carbon compounds. This is important because more than 90% of the compounds in the world are organic compounds. This large number of compounds is possible because of the covalent bond between carbon atoms is very strong, which allows carbon atoms to form long, stable chains. Remember that carbon has 4 valence electrons, and therefore it likes to make 4 bonds, and particularly with carbon. So it can make a chain like this, and then because it can make 4 bonds, you have a lot of opportunity to add other things to this chain, like halogens or hydroxide ions, and most typically, of course, hydrogens everywhere. So that's the reason organic chemistry has its own branch of study. There is a lot of compounds out there that are organic. So organic compounds are typically contain carbon and hydrogen, basically need to contain carbon and hydrogen, but they'll sometimes also have, most commonly, oxygen, sulfur, nitrogen, and the halogens, but they can also have just about any other element on the periodic table. So the rule for, or the formula, when you write the molecular formula for organic compounds, they have a rule that you put the carbon atom first, then hydrogen, and then any other atoms after that. So in this case, this molecule has 6 carbon atoms, 12 hydrogens, and then also has 6 hydrogens. And if there was, say, a bromine too, then the bromine would go, after that. So that's the quick little rule for how you write the molecular formula for organic compounds. Now, the most basic organic compound is a hydrocarbon, and that's where that organic compound only has carbon and hydrogen in it. And since the name, hydro for hydrogen and carbon for the carbon. So hydrocarbons have just carbon and hydrogen. And there's 2 classes of hydrocarbons, either saturated or unsaturated. And those terms pertain to the carbon-carbon bond. If the carbon-carbon bonds are only single bonds, so you only have single bonds between the carbons, then you have a saturated hydrocarbon. However, if any one of these bonds ends up being a double bond, so one or more are double bonds or multiple bonds, then you have an unsaturated hydrocarbons. And the only option really is either a double or a triple bond, is the most you can get with carbon. So if there's any double or triple bonds in the molecule, you have an unsaturated hydrocarbon. So the saturated hydrocarbons that we just talked about is the most basic form of the organic compounds, and that class of compounds are called alkanes. If it does have, like we said, the unsaturated, where you have a double or a triple bond, then if there's a double bond somewhere in there, one or more, it's alkenes. If there's one or more triple bonds, it's alkynes. We won't deal with those anymore in this video, but we will have subsequent videos that talk about those groups of organic compounds. For now, we're sticking with the alkanes, strictly single bonded carbons. Now, I'll also have a video on how to go about naming organic compounds, but I'll do a little bit of that right here to talk about alkanes by going through this table over here. The first 10 alkanes, and what I mean by 10 is you look at the number of carbons, either 1 down to 10 carbons. So if you have an alkane, they're just carbons and hydrogens. So you're going to have, if you look here, 1 through 10 carbons, and then the rest of the bonds will be filled in with hydrogens. And so you'll see you'll come from up from 4 to 22 hydrogen atoms in order to complete the hydrocarbon. So these are the first 10 alkanes, and the naming convention is you start with a root for the name, and then you add on, because this is an alkane which ends in A and E, you're going to put an A and E after the root. So 1 carbon, the root is meth, and you put A and E at the end, so the name of the first hydrocarbon is methane. And as you go on, if there's 2, the root is F, and therefore the hydrocarbon, you fill it in with hydrogens, is called ethane. And so on down for prop, bute, pent, hex, hept, oct, non, and dec. And so you have these first 10 alkanes, and of course you'll be required to memorize. Most courses just the first 10, but of course that 10 continues on to a lot of compounds, so a lot more carbons. Particularly in biological systems, you can have a slew of carbons. So those are the alkanes, and a little bit of naming on the first line of alkanes. Also show here condensed formula, which on the next slide I'll talk more about the formulas. But condensed formula, you would write, you'll see here, you split out. Here's ethane, or let's look at propane. Propane here, in a condensed formula form, you break out the carbons. You have 3 carbons, and then you show the hydrogens on each carbon. So the first carbon has 3 hydrogen, the second 2, and the third 3. And simply if I look over here, propane is 3 carbons. Because each carbon can have 4 bonds, this one here ends up with 3 hydrogens on it. The one in the middle already has 2 bonds to the carbons, so there's only room for 2 more hydrogens. And then the end carbon again can fit 3. So that's why it's a CH3, CH2, CH3 as a way to do a condensed formula. Okay, now if I look here at the little drawing I just did, if I take away one of the hydrogens, and let's put a halogen in there, bromine. That class of hydrocarbons is called a Hallow Alkane. And again, hallow meaning halogen. So it's an alkane with a halogen on it. You see that if you replace one or more of the hydrogen atoms in an alkane with a halogen, either fluorine, chlorine, bromine, or iodine, then you have a Hallow Alkane. And I show that here. You got a bromine on this hydrocarbon, and so you have a Hallow Alkane. That is also sometimes called a substituent. Substituents is a side group or branch coming off the main carbon chain. So if you look at this, the main carbon chain is here, got 3 carbons, and instead of a hydrogen, we've got this unique bromine coming off it. So sometimes you'll just show it like this. It has a branch coming off that's not hydrogen. It's something else. And so this is considered a substituent. And substituents, we have a table here of the most common substituents. And those are, as I just said, the halogens. But they can also be just more carbons. And so if coming off here I have a carbon, this would end up, again, if I filled in with hydrogens, there'd be 3 hydrogens. But now off my main chain, I have a carbon coming off as a branch. And so when you have 1 carbon coming off as a branch or a substituent, the name for that is methyl. And if you notice, that comes from the root of meth, and you add a YL to it. And again, I'll have a video on how to do naming later, but just a little bit of an introduction here. And the common substituents, the most common you come across is meth, ethyl, and propyl. And there is one unique, let me move this a little bit so you can see it better. Isopropyl is a variation on the propyl coming off. And if you think about it, if I have, let me redo the whole thing here. If you have some long chain of carbons, a whole bunch of carbons or whatever coming off. If you have a propyl coming off, there's two ways. Since it's 3 carbons, you're either going to connect on an N carbon, or you can actually, since there's a middle carbon in propyl here, you could connect to the middle carbon. And if you connect to the middle, they just have a special name for that. Isopropyl is the substituent name for that because it goes to the middle carbon. And again, you'll learn more about this in naming. So the last thing I want to talk about is how do you draw organic compounds. And again, I'll try to stay with just the simple hydrocarbons here and alkanes. And there's lots of different ways for chemists to draw organic molecules. And they'll use different methods depending on what they're trying to convey with the drawing. So they'll use different mechanisms here. The first one we talk about is the Lewis structure. This is not too common to use, but you will come across it. And there you're just showing, carbon has your 4 valence electrons. So if I'm just drawing methane, you're going to come in with 4 hydrogens around it. And I'll use an X for the the electrons donated by the hydrogen or shared with the carbon. And so this would be a Lewis dot structure for methane. And this is one way you can show your organic compounds. Now, you can replace those dots with a bond, which is just a straight line. And then that's called a structural formula or an expanded formula. Wherever you have your bonds, you show a straight line. And so here for propane, you see the hydrogens around the carbons, and you show the lines. The lines are either carbon-hydrogen bonds or they're carbon-carbon bonds in there. So that's a structural formula or an expanded formula. The next one shown here is the line drawing or the skeletal formula. This is a very simplistic way of trying to draw the molecular formula. And you can look at it here. Doesn't seem to be much to it, but basically what you're doing is for propane, this is propane that I'm showing there, you have 3 carbons. Now, normally you would do something like this, but if you're going to represent just by lines, if you try to draw a straight line, you don't realize that in the middle here there's a carbon. So what they do is they angle it. So they draw it like this, and at either at an end or a corner, you assume there's a carbon. There's one there, here's a corner, and here's an end. So those are your carbons. And then you also assume there's the hydrogens coming off, 3 on each end and 2 in the middle. So if you assume the carbons and the hydrogens, you can simplify that down to just that drawing like that. And that's a simple way to draw propane. Now if we had a Hallow Alkane, so you had a bromine coming off, say this middle carbon, you would have to, in the skeletal formula here, you would have to show the bromine because you assume the carbons have only hydrogen in this form. So if it's not a hydrogen, you actually have to draw it in. So this would be bromine on a propane base here. The final form for drawing organic compounds is this condensed formula. And really the condensed formula just derives from the structural formula or expanded formula. And instead of showing the hydrogens coming out like we do here and here, we just group them next to each carbon. So if you look here for this propane, the first carbon has 3 hydrogens with it. The second carbon has 2 hydrogens, and then the last one has the 3. And so you can write it this way, and it saves you from going up and down. It's a lot easier, particularly if you're typing in a paper, to draw it this way. And occasionally you'll see if you get a bigger molecule, since if you have a lot of carbons in the middle here, all these in the middle have two hydrogens. So you'll see sometimes the N carbon has three. They'll put a parenthesis CH2 because the middle ones all have two hydrogens. And then you do a sub 3 and then again CH3 for your N carbon. And this tells you you've got three carbons in the middle with two. And therefore this is really pentane. It's a 5-carbon alkane. And that's even a further condensing of this kind of method. So you'll see it both ways. Thank you.